Hello. This week we're going to be looking at projectiles, which is going to take all of our learning from Subat equations, from resolving forces, but in this case we'll be resolving velocities, and it will take our vectors knowledge and throw them all into one big topic. Let's get started. Here is a question to review the learning pack work that you will have studied before the lesson. We have a particle projected from a point O on level horizontal ground, speed 28 meters per second and an angle to the horizontal, and tan alpha, the angle is 3/4. The particle is moving freely under gravity, reaching a greatest height above the ground before it lands on the ground at a point P. So as with all mechanics questions, draw a diagram. So the diagram here, you can see we have this diagonal speed. We've got 28 meters per second. We have the angle that the speed makes with the ground, represented here as alpha, and we have this drawing of the projectile's path. Now the projectile's path, technically, it does form a parabola. They always form a parabola. I couldn't draw a parabola on Smart Notebook, so this is as close as I'm going to get. But the fact that it does form a parabola can be really useful, okay? So you do have to bear that in mind. So we're being asked to find the time it takes the particle to reach the greatest height above the ground. Now, one of the key things that we're going to have to do here is to think about this 28 meters per second, because as with every other aspect of mechanics, whenever we've worked with diagonals, we need to resolve. Now, the reason we need to resolve is we work purely in terms of parallel to the plane and perpendicular to the plane. So when our plane that we're based on here is the ground, the horizontal ground, we need to know what the horizontal component of this 28 meters per second is. Okay, purely horizontal. We also need to know what the purely vertical component of this 28 meters per second is. Okay, and that's what we always have to do. We always have to do that. We have to work out these two horizontal and vertical components. And there's quite a simple way of doing it, and you recognize it from when we resolve forces on inclined planes. We have a right-angled triangle here, where our hypotenuse is our 28 meters per second. We have an angle inside the right-angled triangle, which is our alpha. So this is just our 28 meters per second over here. If I want to resolve this 28 into its horizontal and vertical components, I consider the angle. I look at the vertical one first and realize that this is opposite the angle. And so I have 28 multiplied by sine alpha. And then I look at the horizontal one and realize this is adjacent to the angle, so I have 28 cos alpha. And so a general rule of thumb, really, in the majority of questions you're going to do here, your vertical component is always going to be the velocity multiplied by sine, and the horizontal is always going to be multiplied by cosine. So that's one part. That's a part we need to figure in. The second thing we need to look at in this particular question is the fact that the angle has been given to us in terms of tan. Now, I'm going to draw a separate little right-angled triangle here. Now, this is nothing to do with the question, really. This is just a little demo of where we find sine and cos from. So here's another little right-angled triangle. Just match it up there. Here's our angle alpha. We know that tan alpha is 3/4, so opposite is 3, adjacent is 4, which means hypotenuse is 5. And that means we know that sine alpha is 3/5, and we know that cos alpha is 4/5. And that's just a little kind of trick to help you get sine alpha and cos alpha. It doesn't really relate to the question other than to generate these two values. This right angle triangle here, way more important because it gives us our horizontal and vertical components. Okay, so now we've set the question up. Let's start to answer it. Find the time it takes for the particle to reach the greatest height above the ground. We're interested in the greatest height. So I'm going to do the first of two things that I can do with projectiles, and that's to resolve, R for resolve, arrow pointing up vertically. So resolve vertically. Write this in every time you do a question. You're telling an examiner or a marker a story. Tell them what you're doing. Otherwise, they have to pick through all your working, and it's very difficult for them to mark. So tell them here that you are resolving vertically. And Now we just use suvat because we have a constant acceleration, which is the acceleration due to gravity, and we just work out all the other bits using our suvat equation. So, find the time taken to reach the greatest height above the ground. The displacement vertically then is not anything that we're interested in. We're not asked to calculate the height. We're just told it reaches its greatest height. So we're not interested in the s. The u is the initial velocity vertically, which is given by 28 sine alpha. Okay, now we can work this out. That's going to be 28 multiplied by the 3/5, 28 sine alpha, which comes out as 84 over 5 meters per second. Okay, so that's the vertical component of that velocity. The final velocity of the particle when it's projected is going to be 0. Now that's because it reaches its greatest height. Now what happens purely vertically, when they're ignoring the horizontal completely here, is it reaches its greatest height, it stops for an instant, and then it falls back down to Earth. So we're describing this instant where it completely stops. So the final velocity is 0. The acceleration is minus 9.8 meters per second squared. Minus, because we've decided that up is the positive direction. That's why our velocity is positive, because we said up is the positive direction. That means the acceleration is negative because it's trying to bring the particle back down to Earth. And the time is what we've been asked to calculate. How do we calculate that? We're going to use v equals u plus at and substitute. So 0 equals 84 over 5 minus, so it's not plus anymore just because it's minus 9.8, so we've got minus 9.8 t. V equals u plus at. So rearranging gives 9.8 t is 84 over 5, and we can evaluate this by dividing, and we get 1.7 seconds to figures. Remember, we use two significant figures to round because our acceleration, 9.8, that we use has also been rounded to two significant figures. So that's the time taken for the particle to reach the greatest height above the ground. You can see it's fairly straightforward. All right? Once we have all the pieces in place, once we know what our vertical component of the velocity is, we're just using suvat. Second part, part B. Hence, determine the distance OP. To determine the distance, we're going to be working horizontally. We're going to be working parallel to the ground. All right. Now, here's the interesting thing. As you saw in the learning pack video, and as I've explained a lot in class as well, when we're moving horizontally in these questions, there is no acceleration. The only acceleration acting on the particle is the acceleration due to gravity. When we consider the horizontal motion, it has a constant velocity. And that's a little bit tricky to get your head around, but once you do get your head around that, these questions become remarkably easy. Because whenever we're working horizontally, we're just using the fact that speed is distance over time. Yeah? The speed is distance over time. So it's not even a suvat question. It's just speed, distance, time. So if we're trying to determine the distance of OP, we can just say that, and I'm going to use the vector notation. I'm going to use the s, the u, and the t, just because although we're not using the constant acceleration, it's what we're used to using in this question. So find the distance, I'm going to multiply the speed by the time. So s for the distance, the horizontal displacement, is the speed, which is the initial velocity, multiplied by the time. You'll see it's almost like the equation ut plus half at squared, but the acceleration effectively is 0. So the distance then is the speed, the horizontal speed, which is 28 cos alpha, multiplied by the time. Now, first thing, 28 cos alpha is going to be 28 multiplied by our 4/5. So 28 multiplied by 4/5. and we get 22.4 multiplied by t. Now here's where I spoke earlier about the fact that the motion of the particle forms a parabola in the air. That's important because a parabola is entirely symmetric about its maximum. Okay, so this kind of negative parabola, if we had the maximum point, is symmetrical. And that means the time that it took to reach its greatest height will be the same as the time that it takes from the greatest height to reach the ground. So we have that symmetry. So our speed then is just going to be given by 22.4 multiplied by 2 lots of the 1.7 from previously. So we'll keep the 1.7 rounded in our calculator, and we will use that. So we'll multiply by 2, so multiply by 2, and then we will multiply by 22.4. And what we get is 77 meters rounded to 2 significant figures. So there we have it. This is a fairly standard projectiles question. Resolve your velocities. Resolve vertically. Resolve horizontally, and calculate all of your missing things. So example 2 is very similar. First things first, get your diagram on the page. Here we have a speed of 45.5 meters per second, and we have an angle given by beta, and it's the same setup. You can see the pattern. Okay, if tan beta equals 12 over 5, then sine beta is going to be, if it's 12 over 5, then 12 is the opposite side, and the hypotenuse, I can use Pythagoras on those to get 13. So sine beta is going to be 12 over 13, and cos beta is going to be 5 over 13. And in case you are wondering, it's this triangle here. Very roughly drawn, but hey. So with this triangle, we have our angle beta, we have 12 here, 5 here, and we can work out that the hypotenuse is 13 using Pythagoras there. So it's moving freely under gravity, reaching a greatest height. Same as before, find the flight time of the particle. Slightly different question this time. So first thing I'm going to do is I'm going to resolve vertically, which means I'm going to use sumat. And I'm going to interpret the question. So the flight time of the particle is the flight time between O and P. One thing I know about between O and P is the vertical displacement is 0, because it's in exactly the same position vertically at P as it was at O. So although it's traveled the distance, its displacement is actually nothing. That's purely vertically. The initial velocity, remember, is our component to the 45.5. So we've got 45.5 multiplied by sine beta, which is going to be 45.5 multiplied by 12 over 13, which is 42 meters per second. The final velocity, we're not interested in. We're not being asked about the speed when it hits the ground, so we're not interested in this at all. The acceleration is minus 9.8 as ever, and the time is what we've been asked to calculate. So we go to our Suvat equations and we realize that S equals ut plus half at squared is our equation to use. We substitute in our known values, u times t, so we're 42t, plus half a is minus 4.9. And so we can factorize this, which means that t equals 0, as we knew, because where does it have a vertical displacement of 0? At the start. And then the next solution will be the one we're interested in, which is at the end, which is going to be t is given by 42 over 4.9, which is 8.6 seconds to 2 significant figures. So there's our flight time, okay? Just a very quick run through. Resolve vertically, okay? We took our component of the speed, and that was our initial velocity. Our final velocity wasn't relevant, minus 9.8, our old friend, and then we worked out the time. So it says, hence determine the distance OP and the value of h. Now, h is the value of the greatest height above the ground. So if we want to determine the distance OP, I can resolve horizontally, and I can say that displacement is speed times time. So displacement is going to be 45.5 cos alpha, because it's purely horizontal this time, multiplied by my 8.6 from the previous part of the question. So 45.5 cos alpha, remember, was 5 over 13, and then multiplied by 8.6, and then we'll work that out. And we have 150 meters, using the unrounded version for this 8.6. So then we've got to find the value of h. So this time I'm going to resolve vertically, which means suvat, because that's where the acceleration is. S is what we're being asked to work out, what's the greatest height above the ground. U was the same initial velocity from previously, 45.5 sine beta, which is 42. I should have used beta here, but never mind, you get the drift. It's 42. The final velocity 0, like in the last question, its greatest height means it stops instantaneously. The acceleration is minus 9.8. And I mean, we're off and running here. We can do it in a couple of different ways. You could put the time as half of the 8.6, but we have enough information already. So I'm going to use v squared equals u squared plus 2as. So 0 is 42 squared minus 19.6s. So s is 42 squared divided by 19.6, which we can very quickly work out is 90 meters. So the greatest height reached above the ground is 90 meters. And then we get into something a little bit more interesting. We get this, find the question, determine the speed of the particle 4 seconds after leaving O. Right. So this is where we've got to think about the speed. Okay. Now, when it's 4 seconds after leaving O, chances are it's traveling in a diagonal direction with regard to the ground, which means that the speed that it's traveling at will have a horizontal component and it will have a vertical component. And it's those two things that we actually need to work out, right? Because once we have them, we can use Pythagoras' theorem to work backwards. So if we need those two things, let's have a look at the information we've got. We can resolve horizontally, right? And we know that the speed is 45.5 cos beta, which we worked out previously, or we didn't work out previously, but we calculated as part of the calculation previously, and it came out as 17.5. So our horizontal speed is 17.5, and remember, that's because it's constant. There's no acceleration, so that is a constant speed. Now let's find our vertical speed. And whenever we go vertical, we have to use suvat. You will use suvat a lot in these questions. So we know the time is 4 seconds. We know the acceleration is minus 9.8. We're trying to work out the final velocity at that point, and we know that the initial velocity was 42. Again, that's the 45.5 sine beta. So v equals u plus 18 will give us the velocity. V is 42 minus 9.8 multiplied by 4. So the velocity is going to be 40. Calculator my function. 42 minus 9.8 multiplied by 4, which is 2.8. So our vertical component is 2.8. To find the speed then, we need to use Pythagoras theorem. So we say that the speed is the square root of 17.5 squared plus 2.8 squared, which is given by and we've got 17.72, so we've got 18 meters per second to 2 significant figures. Now that's quite a common type of question, so do look out for it. And then we've got 2 more to look at in the context of the lesson, and then we're done. So now we're going to look at an example which is just a slight jump forward from the work that you've done already. We've been mainly, or at this point, we've been projecting from horizontal ground. That's not always going to be the case in a question that you're going to have to answer. Sometimes you have cases like this where an item is projected from a distance above the ground. And it just adds in one other factor to our calculation. There's nothing else really changes. So firstly, we've got this projected with speed of 35 meters per second. So that means that we need to resolve that speed into its vertical and horizontal components. And we've got sine alpha is 4/7, which means we're going to need to find cos alpha and, well, actually not tan alpha this time, just cos alpha. So let's do that first. If we've got sine alpha is 4/7, then we can think of Pythagoras theorem again. Again, just to kind of draw the little triangle that we're talking about here. But if sine theta is 4/7 by alpha, then 4 is our opposite side, 7 is our hypotenuse, alpha is our angle, and we can work out what this side is. And we've got 7 squared minus 4 squared, square rooted. We've got root 33, and we'll just leave that as root 33. So our cos alpha is going to be root 33 of 7. So it's not a nice number, but it's still a number that we can use. So let's look at A. We've got to find the greatest height above ground achieved by the particle. So we're resolving vertically for this. So we have suvat because we're resolving vertically. And we'll just fill in the bits and pieces that we need. So we need the displacement vertically. We're going to work that out. U is our initial velocity vertically, which is going to be given by the 35, which is the speed, multiplied by sine of alpha, which is the same as 35 multiplied by my 4/7, which is 20. Next, we have the final velocity. Well, we know already that when it reaches its greatest height, the final velocity is going to be 0. And then we have the acceleration, which is minus 9.8. And we have 3 things out of 4, so we're ready to go. So we can use v squared equals u squared plus 2as for this. 0 is going to be 20 squared minus 19.6s. And so s is going to be whatever we get when we do 400 divided by 19.6. So s equals 20.408. Now, I've not rounded that yet, simply because we're asked for the greatest height above ground. Now, the particle is already 22.5 meters above ground when it's projected. So this displacement tells us that after it's projected, it reaches a further 20.48 meters. So we need to take those 2 values and add them together. So the height is given by 22.5 plus my 20.408 ... and then we'll round it afterwards. So we have 43 meters to 2 significant figures. Next, show that the flight time of the particle from O to A is 5 seconds. So for part B then, again, we're going to be resolving vertically. And we're going to look at the fact that from O to A, when we're working out the displacement that it's traveled, it's actually going to have traveled minus 22.5 meters, because again, up is our positive direction.
everything that moves up is positive, everything that moves down is negative. So we have a displacement of minus 22.5, and we can fill in the rest. So again, our initial velocity is the same as this. It's 35 sine alpha, which came out as 20 meters per second. The final velocity is nothing that we're interested in. We're interested in time. So our acceleration is minus 9.8, and we're asked to work out the time. So we'll use s equals ut plus half at squared. So minus 22.5 equals 20t minus 4.9t squared. Gives us a nice quadratic of 4.9t squared minus 20t minus 22.5 equals 0. And we'll go to the equation solver on the calculator for this. I recommend that's what you always do. Don't try and use any complete in the square or quadratic formula or anything. Just go with your calculator. Examiners don't care. So 4.9 squared, then minus 20, and then we've got minus 22.5 at the end. And our solutions come out as t equals 5, and t equals minus 0.918. Now, why is one of those times negative? Well, we're asking in this model where the particle would be level with the ground. And the 5 seconds comes from the right answer, which is where it reaches A, but the negative is where it's almost like backwards in time. Okay, it's finishing off the parabola shape. It's the time when it would have intersected with the horizontal again. And of course, you can't have negative time. So our answer is 5 seconds. So then for part C, very similar to what we did before, determine the speed and direction of the particle as it reaches A. Well, we can see from the model that when it reaches A, the speed at which it's traveling is going to be this direction. Okay, so that's its speed, and what we're going to calculate is its vertical velocity and its horizontal velocity as before, and we're going to then use Pythagoras theorem to work out the speed. So let's do that. We can do the horizontal one quite straightforward first. We're just using the fact that distance equals speed times time. And so if we put in what we know, determine the speed and direction of the particle when it reaches A. So it's 5 seconds is the time, and the initial speed is going to be 35 cos alpha. So we're going to have 35 cos alpha. Forgive me. We just know that the horizontal speed is 35 cos alpha. That was me getting distracted, unfortunately, by something in the window. So horizontally, because there's no acceleration, we know that 35 cos alpha is our speed. So we've got 35 cos alpha right there. Vertically, we're going to need to do another SUVAT. So we've got S, U, V, A, T. You can see how often we're doing the SUVAT calculation. S is not something we're interested in. U is going to be our 35 sine alpha, which was 20. V is what we're trying to calculate. The acceleration is minus 9.8. And the time that we're interested in is 5 seconds. So we're going to use V equals U plus AT. So V is 20 minus 9.8 multiplied by 5. And when we put that into our calculators, 20 minus 9.8 multiplied by 5, which is minus 29 meters per second, which is absolutely fine because we know that this velocity would be negative because we said that up was positive, and so that just tells us that we've got 29 there. So we'll use Pythagoras theorem, and we'll say that the speed is going to be equal to the square root of the 29 squared plus the 35 cos alpha squared. Now 35 cos alpha was our 35 multiplied by root 33 over 7, which is 5 root 33. Okay, that's our 35 cos alpha. And we get the speed then. Which comes out as 40.816 dot dot dot, and two significant figures, therefore we've got 41 meters per second. So again, everything is exactly the same. You still have the same processes. You resolve vertically using acceleration and suvat, resolve horizontally using speed, distance, and time, and you're off and running. So I'm hoping that you can see the pattern in these questions. There is a second question, and the second question I've got the complete working for. What I recommend you do is to, when you see the second question, just pause the video, work through it, and then check your answers with my answers. Okay, so pause the video. You can already see the start of the working at the bottom, but pause the video, do the question, and come back. Okay, now that you've paused the video and done the question, there is my working.